With the purpose of compare the effects that appear among the used methods, I have used the Friedman test to detect the difference in results across the numerical experiments. The null hypothesis for this test is that there are no difference between the used methods. I have used to compare the results obtained regarding the average computational time in all methods and to identify the methods that reduce the computational time. After the test, it was concluded that we cannot accept the null hypothesis and seems that the methods produce different computational times. It is possible also to perform a post-hoc analysis to detect which of the methods offers the bigger difference. Box plots in this figure show that the NIMS method outperformed the results obtained by the other approach, but it is also possible to obtain reduction by using diversification procedures. Also, with the purpose of evaluate the difference that could appear as an effect of the programming language, as previously I said that Python seems not to be as fast as we wish. A simple algorithm was implemented in C++ and Python to compare the difference regarding computational time. The bubble sort algorithm was used as a comparison point. The obtained result shows that for all instances size, Python takes an average of 5 times the time that use C++ to solve the same algorithm and the same instance. It is not sure, but seems possible that implement the genetic algorithms in a faster programming language could lead to obtain better results for the proposed methods. Also, it is possible to improve the genetic algorithm that I have implemented, and actually I'm taking a course right now in algorithm design and analysis, and I think that I could use some techniques to improve my previous programs. Also, I wish to know other methods to improve the convergence of the column duration algorithm. One of the methods that I have tried was to use a good initial solution to initialize the method, and two methods were used. The first one uses all the possible subsets that include only one sensor, just one sensor active by each subset, and by the second approach, a simple method was designed to generate appropriate columns. The proposed method was quite simple. First, it iteratively selects for a subset sensors that have a few targets covered by the other sensor. Also, the method selects iteratively sensors that significantly reduce the breach coverage and are not used previously in the covers that has been previously generated. The proposed heuristics use some different weights, alpha, beta, and gamma, to obtain an index calculated and used to generate the cover. Some experiments have shown that to maintain all the generated cover could be expensive regarding to computational time. A simple deletion scheme was proposed to avoid this problem. The proposed method deletes the columns that are not part of the optimal basis by a predefined number of iterations. The conducted experiment shows that, as expected, the computational times could be reduced by implementing a deletion scheme. However, It is possible that some useful columns will be also deleted and the number of iterations could be decreased. What actually is not important if the computational times are reduced, as you could observe. As you could observe, the number of iterations could be larger, but there exists reduction in the computational times. To summarize, I have been working on the minimum convergence bridge problem with emphasis on improving its convergence when solved using the column generation algorithm. The results have shown that the use of stabilization and diversification procedures could be useful to diminish the number of iterations required to solve the problem. However, it is necessary the design of efficient programs that avoid to take even more time than the classic column generation approach. The result shows that the NIMS method could effectively accelerate, regard to computational time, obviously, the overall convergence of the algorithm. Also, it was possible to observe that the box-plane-based methods could increase the complexity of the problem, and at each iteration, the computational time for the auxiliary problem could be increased. For the proposed methods, it was observed that they require a lot of tuning work, so the methods could be successful just after a complex calibration process. I think that it could be interesting to analyze the results in a faster programming language than just Python, and the use of hybrid approach that take the best of all the proposed methods. For example, to use relation with the genetic algorithms or initialization with the stabilization such that the overall performance could be increased. Okay, it was all that I wish to present you. I'm sorry for my English skills. I'm working on that. I'm in a graduate English for graduates students course, and I think that in a couple of months my English skills will be better. Thanks for your attention, and I'll be, or your comments will be welcome. Have a nice weekend. Thanks.